It's time to speak about the Ethernet. This is lesson 7, and soon we are going to finish CCNA routing switching book number 1. And first of all, we'll take a look with you for the history of the Ethernet. The Ethernet firstly being published in 1980 by the consortium of 3 organizations, Digital Equipment Corporation, Intel, and Xerox. They wanted to make the Ethernet so that the Ethernet will benefit for everyone. That is why they made this standard as an open standard. The first product that were developed from the Ethernet standard were sold in the early 1980s, and in 1985 the Institute of Electrical and Electronics Engineers IEEE Standard Committee for local and metropolitan networks published a standard for LANs, local area networks, and this standard starts with the number 802. And the standard for the Ethernet now is 802.3. So when you speak about the classical Ethernet, then you speak about the IEEE standard 802.3. And the Ethernet consists of 2 layers of OSI model. They are data link layer and the physical layer. Whereas a data link layer, as you remember, consists of 2 parts of 2 sublayers like LLC, logical link control, which works with the upper layer, and the media access control, which works with the lower layer, with the physical layer. And the Ethernet standard has the IEEE standard 802.3, and this actually consists of 802.2 also. Early Ethernet, media, and topology. Previously, there was the situation like the topology. The physical topology was the bus, and logical topology was the bus. But afterward, our physical topology, migrated to star because we started to use the centralized equipment like a hub or the switch. So nowadays, when you speak about the Ethernet topology, so physically it is star topology, and logically it is a bus topology. So logically it means that so if you have computers like A, B, C, D, and so on, E, F, G, and when your computer A wants to send information to computer G, for example, this communication will travel by a shared media, like by a bus connectivity. But physically it is interconnected. They are interconnected by the hub, because hub's functionality is actually described right here. Hub-based communication. So it's not. So maybe you will not find the hub nowadays in your organization, or maybe even if you want to buy a hub for a LAN connectivity, maybe you will not find it in the store. And the hub is such kind of equipment which is receiving the signal, and afterward which is resending the signal to all other equipments. Okay, it's like sometimes it's called as a repeater. And the switch-based communication, switch-based Ethernet, is like the communication by using MAC addresses. And if computer A wants to send information to computer B, then computer A will be able to do it just without wasting the time of other computers, so that they will not receive this unneeded information. Well, as we mentioned before, with the switches we are using MAC addresses, and MAC address consists of 48 bits. 48 bits. It is represented in hexadecimal, and it is divided into 2 parts. So the first 24 bytes describing the OUI, organization unique identifier, and the second 24 bits describing like a vendor assigned NIC cards or just an interfaces. Okay, so that and as I mentioned before, it is represented in the hexadecimal, and hexadecimal has from 0 to F values, and MAC address can be represented in different ways. Like you can see dash, you can see colon, or you can see just dot after 4 symbols of the hexadecimal value. How to identify MAC address? In your computer, you can just type the command IP config all, and afterward you will see the result of your MAC address. For example, if I will do the same from the CMD, so let me just open CMD and type here IP config all, so I can see here all of my network interface cards information, but due to that fact that my wireless interface card is not working or working. Here it is, yeah. So here it is. This is my network interface card. So MAC address A434 and something like this. And we also have I also have Ethernet adapter, which has this MAC address. So I have two network interface cards, and these two network interface cards, each of them have by one MAC address. Let me take it off, so I don't need this connectivity now. The differences between IP and MAC addresses. IP addresses are used to communicate between networks, and MAC addresses are used to communicate inside local area network, inside single network. Let's take a look for the mechanism which is called the CSMA CD, carrier sense multiple access with collision detection. And maybe we already familiar with this mechanism, but we'll take a look for this mechanism one more time. So as we mentioned before, in standard Ethernet, when our logical topology is a bus, what does it mean if our logical topology is bus? It means that all computers are connected to shared media, and all computers can hear the communication of other devices. And this example is when you are connecting by using the hub. What happens? Computer C wants to send information, and before sending, it is listening for the media. So if someone is already sending information to another computer, then computer C will hear it because they are on shared media. And in our example, computer C understands that there are some communications in use right now, and that is why computer C will wait. Okay. After waiting, computer C will try to listen for the media one more time before starting to send the information, and computer C understands that there is no communication happens right now, and computer C can send the information. And now in our example, we have such kind of situation like computer D and computer A are listening for the media at the same time, and they understood that there is no communication happens right now, and when they start to send information, their signals are collided with each other, and there is the jam signal happens for all of the devices. All of the devices understand that. So jam means that the level of the signal is changed due to that fact that we had the collision, and all of the computers after understanding the situation, they are placing their backoff timers, and the backoff timer is the randomly selected countdown timer by each computer. After this timer will be finished till 0, then the device will start to listen for the media one more time before starting to sending the information. This mechanism is called the CSMA CD, but there is no guarantee that after computer A and computer D made up the collision, and after they will start the countdown timer, there is no guarantee that their countdown timers will not be same. There can be situation like they will have collision one more time, and then this CSMA CD mechanism will work one more time. Hubs and collision domains. So we have when we are interconnecting our network by using hubs, then we have such kind of rules. So this rule says that there must be not more than 35 hosts, and there must be not more than 5 hubs in that network. Why? Because in case if your network will be larger than this value, then imagine that when computer A sends information to computer B, it is sending this information right here and to all other directions, including the next hub and next hub and next hub. So all of the other devices will receive this information. And imagine that if you have all of these devices which are trying to make communication at the same time, then there will be too much collisions and your network will not have a good performance to provide the connectivity between your equipments. Alright, let's continue. We have timers in the Ethernet. An Ethernet frame takes a measurable time to travel from the sending device to the receiving device, and each intermediary device contributes to the overall latency. So we have a latency in our communication, and let's take a look for the Ethernet timers which we have. We have first timer, which is called the beat timer. It is required time for beat to be generated by an end device. So when your end device is making a signaling on the physical layer, it takes time for this end device to generate the signal. And for example, if your network connectivity is 10 megabits per second, then your equipment have to have time to generate this 10 megabits per second. And this timer is called the beat time. So as you see here, for the different types of the speeds, we have different beat times. Like for 10 megabits per second, it is required 100 nanoseconds to generate 1 bit signal. In 100 megabits per second is 10 nanoseconds. For 1 gigabit, and it is 1 nanosecond. And for 10 gigabits, it is 0.1 nanosecond to produce 1 bit. Well, we have also the slot time, is the time it takes for electronic pulse to travel the length of the maximum theoretical distance between two nodes, and the maximum theoretical distance inside the local area network is 2.5 kilometers. This is also the same time that a transmitting station waits before attempting to retransmit following as a collision. And let's take a look for the timers. Like when you have a speed of 10 megabits per second, then you have 512 bit times. So this is called the slot time. Or if you'll take a look for the time interval, it is 51.2 microseconds. And so on. So for 100 megabits per second, for gigabit, for 10 gigabit. All right, let's continue. Also, we have as a timing interval, we have interframe spacing. Well, when our device is generating multiple frames, I mean in a queue by order, so after your device generated one frame, it has to wait for the interframe spacing. And here we have also speeds 10 megabits per second. It is taking 96 bit times, so it's equal to 9.6 microseconds. So after your switch or after your end device generated first frame, it has to wait for this amount of time before starting to generating a next frame. Well, if you'll take a look for types of the Ethernet, so you may see here different types of the cables, you may see different types of the distances of the maximum distances that the signal can travel without retransmitting, and you can find here different speeds. So you can take a look for this table by yourself. We will not pay attention on describing all of them one by one. We'll just take a look for 10 and 100 megabit Ethernet. When you are using 10 and 100 megabits per second Ethernet, then you have actually 8 pins, or like 4 pairs, but only 2 pairs are working. They are, so pair number 2 and pair number 3, only they are working. These pairs are not in use. You can even take them off. And you can see here that the pin number like 1 and pin number 2, they are used to make a transmission of the data. And whereas one of them, like pin number 1, this is a positive, like a plus, and pin number 2, it is negative, minus. and pin numbers 3 and pin number 6 are used to receive the data, and also positive and negative, and pin numbers 4, 5, 7, 8 are not in use, so you can take them off and you will have absolutely the same connectivity. But in case when you have 1 gigabit per second or even higher speed, then all of the pins are used in the full duplex connectivity, so that you you have ability to have such kind of high speed, due to that fact that through single pin you have you can send information and you can receive information at the same time by using the phasing of the signals. Alright, hub-based Ethernet is providing for you a lot of collisions in the network, and the switch-based Ethernet is providing you collision-less communication. And each port of the switch is called, so as you see here, switch port is connecting to the hub, and hub connects to such kind of end devices. Each port of the switch is called the collision domain. So if you have a lot of computers which are directly connected to switch, like 1, 2, 3, 4, I think that here we have 16 connectivities from the switch, then you have in this example 16 collision domains. But in this example you have only 2 collision domains. Alright, let's continue. Alright, now we'll take a look for the functionality of the switch, how switch is making a selective forwarding. Well, a switch use the MAC address table, and switch use the destination MAC address field in the frame. So that let's take a look for this example. Computers are sending information to the switch, and switch looks for the destination MAC addresses of these frames, and afterward it is finding from the MAC address table where to resend this information. I mean where to resend these frames, and after finding them, I mean the value, I mean the number of the port, switch just resend this information. So, and here we have a logical view of the same operation. Frame came to the port of the switch. So the switch placed the frame into the memory buffer, and afterward switch search where to, to which port it has to resend this information by using its MAC address table. Let's take a look. Okay, switch understood where to resend the information, and afterward packet have to be resent from the buffer to a proper port, and for the second frame too. Alright, let's continue. We have switch operation modes. They are learning mode, aging, flooding, selective forwarding, and the filtering. Let's take a look for this different types of the modes of the switch port. Learning, flooding, and selective forwarding. First of all, when you turn on the switch, in your switch there is no MAC address table. There is MAC address table, but it's absolutely empty. And when computer A or host 1 start to make communication with, for example, host 2, then our host 1 is sending a frame in which we have source MAC address and destination MAC address. Switch immediately understand that port number FA01 is connected to 0A MAC address. This is just an abbreviation of the MAC address, and switch immediately writes this information into the MAC address table. So this process is called the learning, because switch is learning which MAC addresses are connected to which ports. What happens next? afterward, switch doesn't know where to resend information to MAC address 0C, because in your switch there is no information about this MAC address. That is why switch has to resend this information to absolutely every other port through which it has any kind of connectivity. And look, switch sent this information through port FA03, FA06, and FA08. And this process is called the flooding, because switch doesn't know where this 0C MAC address is located. And afterward, only computer 0C is giving reply, and when reply came to the switch, switch immediately write the information. Oh, I got connectivity, I have connectivity with 0C MAC address through FA06, through FA6 port. And afterward, switch is able to make a selective forwarding, because it already has this information about MAC addresses of these two computers. So when computer host 1 will make communication with host 2, now switch is able to provide a direct connectivity between them, and this mode of the switch port will be called the selective forwarding. Also, we have an aging time for the switch port, for the MAC addresses on the switch ports. Every MAC address is stored in switch MAC address table for predefined time. After time expires, MAC address is deleted from table. In Cisco Catalyst 2960, default aging time is 300 seconds. It means that it's 5 minutes, and can vary from 10 to so how many seconds do we have here? 0, 0, 0 till up to 1 million seconds. And 0 second defines that aging is disabled, so that if you place the 0 as an aging time, then you will not have aging at all on your switch port. And why do we need to have the aging time? We need to have aging time because we may have such kind of situation, like you are connecting host with MAC address OA, and switch understand that, all right, so on port FA0, on port FA1 I got the MAC address OA, and if you don't have this aging time but you've been disconnected from here and you've been connected to another port, so that switch will understand, all right, I got 0A MAC address here and 0A MAC address on this port. So, and switch will be confused, and it's not actually a good idea to take off the aging time or to make the aging time too long, because in mostly our networks, even if it is local area network, we have a lot of dynamic changes in the network. That is why switch have to know about these changes. Alright, also we have the protocol in Ethernet, which is called the address resolution protocol, which is helping to our devices to find MAC addresses by using IP version 4 addresses. And we have two types of the communication where ARP is used: inside local network communication and outside local network communication. Let's firstly take a look for the inside local network communication where the ARP is used. And what happens? So let's take a look for this scenario. Computer A need to send frame to 10.10.03, but computer A doesn't know MAC address of that IP address owner. That is why our computer A is sending a packet type of the protocol ARP, and it is sending it to all other equipments inside the local area network. And inside this packet there is information. If your IP address is 10.10.03, please tell me about your MAC address. Okay, and afterward, computer C is sending a unicast packet also by ARP protocol, which will provide information to computer A about MAC address of that computer C. And afterward, computer A will store this information in the cache of the ARP table, and then it can make communication with computer C. so that in case when you want to see your ARP table in the computer, on your computer, then you are able to do it. So let me be connected to the proper access point if I have it. So I don't have my access point, which is looking from here. So let me just show you the command which will show you this table, ARP-A. So I don't have any ARP entries because I don't have a network connectivity. But in case if I will have the network connectivity, then I will see here first of all IP address and afterward MAC address. And in case if you want to delete your ARP table, you can type this value and saying that there is no table, that is why you are not able to do it. Or you can add the ARP value by yourself like this. So you'll provide here an IP address and afterward you'll provide the MAC address. All right, let's continue with you guys. And an outside local network connectivity. Let's take a look for this situation. Our computers say that I want to send information to 172.160.10 IP address, and look, this IP address is out of our network. That is why our computer A immediately will generate the ARP to find out the gateway's MAC address, because by using gateway, computer A is able to communicate, and all other computers inside this local area network are able to communicate with foreign IP addresses. And afterward, in the same way, but searching different IP address, our computer A is sending this information. Then our gateway is sending the reply and say that, look, this is my MAC address. And afterward, computer A sends information, send the data packet, data frame to the router, and afterward, router will search for the MAC address by itself. And it's also called the Proxy ARP. All right. ARP issues. ARP provides some. It makes services for our computers, but also provides some issues like a broadcast overheat on the media. It is sending often the broadcast. I mean, our computers are sending a lot of broadcast to find any MAC address in the local area network. And also there is the security issue, because there can be a device which can just filter all of this broadcast communications and understand the structure of the network. This is the end of this chapter. I hope that this video lesson been informative for you. And in case if you have any questions, in case if you have issues with understanding the subject, you can just write me to my emails. And I hope to see you again soon. See you guys.